guys, welcome again. This is an engineering mathematics question paper, KNEC Diploma Mechanical Engineering. I'm going to assist you to tackle question 6b of this question. I had assisted you to tackle question 6a in the last video. Question 6b basically talks about using the Newton-Gregory formula, forward defines interpolation formula to determine the function of x of this function of negative 0.2 and function of 5 using that table. That table is there. Okay, first of all, using this table, we need to construct a finite difference table for us to proceed. Okay, let me show you how to construct a finite difference table. You fill in this, we'll be given x and function of x values. You put them like that, then you construct. You fill in what we have been given. Okay, you have been given first value of x is -1. You leave a space, you then say 0. You leave a small space, you say 1. A small space, you say 2, 3, 4. Okay, again the values of function of x: 1, -3, -7, -5, 9, and 41. Okay, after representing this data in this form, you come, you say first differential is represented as d function root o. You come here. How do you find it? You say -1 minus -3. You put it there. -4, -7, -3 minus -7. Okay, it's okay. When we minus these two, you get -4 again. When you minus this, you get 2. When you minus this, you get 14. When you minus this, you get 32. Second differential. Hope you are getting second differential. When you minus this, you get 0. When you minus this, you get 6. When you minus this, you get 12. When you minus this, you get 18. Okay, the third differential. When you minus this, you get 6. When you minus this, you get 6. When you minus this, you get 6. When you find them being equal, you stop there. After you've created that table, this is called the finite difference table. It will assist us in finding now what we call f of -0.2 and f and function of 5. Function of -0.2 and function of 5 as required in our question here. So first of all, we start with function of -0.2. How do we start it? How do we start? So we start by asking ourselves, where does function of -0.2 lie here? Probably lies between -1 and 0. So what we do, we say it lies between -0.2 lies between here. So we start by finding XO. XO is now XO is now -1. It's equals to -1, and X1 is equals to 0. So this is the XO, this is the X1. So XP is the value we want to obtain, which is negative 0.2. Okay, we come and find the height H. Height H is equals to X1 minus XO. What is X1 is equals to 0 minus 1. So H is equals to 1. After finding H, we come and find P. P is equals to XP minus XO over H, which is P is equals to negative 0.2 minus 1 over 1, which is equals to negative 1.2. Okay, we have found XP, H, and P. Okay, this will help us in our formula, Newton-Gregory forward formula. Okay, the Newton-Gregory forward interpolation formula is function of XP is equals to FO plus P dFO plus P into bracket P minus 1, okay, second derivative, all over that one, plus P into bracket P minus 1, P minus 2, close the bracket, third derivative, divide by that one. Okay, what do we do next? We now find our values here so as to substitute. Our values are in the table. So we come here and say, cut there, then cut there. We are going to use these values that are inside this, what we have cut. So we say FO is equals to negative 3. You see? DFO is equals to, first derivative is equals to negative 4 from here. Second derivative is equals to 6. And third derivative is equals to 6 also. So we have found that, and we had earlier found that XP is equals to negative 0.2, P is equals to negative 1.2, and H is equals to 1. H is equals to 1. So we come and substitute this into this formula. What we have into this formula. After substituting what we have here into this formula, we'll come up with that. Remember, when you find something like this, it is equals to 1 times 2 times 3. When you find something like this, this is equals to 1 times 2. So when you calculate this and fill in your calculator, you'll find that F negative 0.2 is probably equals to 1.272. So we have found the function of negative 0.2. We'll use this to find the function of 5.